I'm Ben from danthemathman.com. Welcome to this tutorial where we will give helpful and easy insight on simplifying radical expressions.
Although simplifying a radical expression looks daunting, it's quite simple when you follow easy steps.
Radical expressions are represented as a monomial, binomial, or polynomial under a square root. One important rule is that everything must be simplified, and when we learn to simplify the fractions, you are unable to have a square root in the denominator.
When starting out with simplifying radical expressions, an easy way to start out is to use the half-power method.
We say half-power method in quotations because it's not so much as a method, but more a different interpretation as an existing method.
First, we will start off with the easiest problem available to give you an idea of how to simplify the radical expressions. In general, square roots in the math world are seen as multiplying a number by the half power. Also, when you get a number, you must find possible square roots that go into it. We can apply this to the problem square root of 81m to the third. The first step is to factor 81 into the smallest squared number. The basic perfect square roots are used 1, 4, 9, and 16. So first what we want to do is we want to take 81 by itself and we want to break it down into square roots. So one of the easiest square roots that you can find that go into 81 is 9. So essentially 9 squared equals to 81. So basically now we're going to start using the half power method. So in this parentheses we're going to put 9 squared. I'm going to get to the rest later, but let me show you how to do m to the third power. So basically, you want to split the m to the third power into two parts. So if it's odd like this one, you want to have m squared and m to the first. You can never, if it's going to be m squared, then it's just m squared. But if you split it into two when you always split this into two. So
When it's odd.
Yes, that's right. After we get these two numbers, we'll put this in to this half power method, parentheses, so m squared and m to the first. So the reason we do the half power method is because basically when we power it by 1/2, it's essentially the same thing as square rooting, because square rooting is also you just put into half, right? So you just put in, do the half power method. So you multiply each of these by 1/2, so you'll get 9 to the first, which is essentially just 9. Then m to the first, and then you get for this one, m to the half. So after you do this, basically you want the numbers with the power of 1 to be on the outside. So you have these two, 9 and m have the power of 1, so you'll have 9m here. And then with m to the half, you want the ones with the half to be on the inside. And this is your final answer, fully simplified.
I just want to point out also, any number 1 or greater would go on the outside. So for example, if this were to be 9 to the 8, just a random example, but if 9 were to the 8, then the 8, and because 1 and greater, any exponent 1 and greater will go on the outside. And any exponent that is 1/2 will go on the inside.
The next problem we will complete is quite similar to the other one. It is square root of 8 over 3 and the third power. Now, if you remember what we did before, basically, to make it easier for yourself, put this in the square root and this in the square root, as it's all technically in the square root. Now let's multiply the numerator and denominator by the denominator. So it's square root 3n to the third times on the numerator, square root 3n to the third. So if you multiply these two together, what will happen is you'll get square root of 9n to the sixth, and if you unsquare that, it just becomes 3n to the third without a square root. Now, since these two are in the square roots, what you can do is multiply them together like any other number. So 8 times 3 is by the way, it's all in the square root, 24. N to the third. Now, we have this answer, but we have to go simplify the numerator. So, we're going to take 24, n to the third, and like we used from other concepts, we're going to take the 6 and 4, which can break into a square root. What we need is exactly what we need, and a 3 and a 2. We don't need a square root here. Remember, this is to the first. So now we want to use that half power method that we were using. I'm not going to get to n to the third yet. I'll get to that later. But, so we'll put 2 squared times 3 to the first times 2 to the first. You always want to put the first even though it just equals this number. So right now we have that in the square root. Now remember what I said you have to split the 3? Thank you. You have to split the 3, so it'll become n squared and n to the first, right? Because you have to split it. So then we'll have in the n part n squared n to the first, and all of this will become a 1/2 because it's essentially the same thing as square rooting it. Would you like to explain this?
Okay, so now what we have here is we have a half power, a half power, and a half power. And as we know, the half powers go on the inside in the radicand, and the ones with to the first power and higher go on the outside. So we're just going to do that right now. All the ones on the inside, I have a 3, I have a 2. I can multiply these together because they're the same exponent to the same value power. So I'm going to get 6, and I look and I see I have an n to the half power, and I just stick the n,
Perfect.
the end of it, and then what I see, I look and I see which ones are to the first power and higher, and I see, oh, I see a 2, I see an n, so I'm just going to stick the 2n over here, and now Will is not going to explain, the rest of the problem.
Okay, so remember, this is your numerator. I just want to recap. And so this will be your numerator. This is basically just this, simplified. Perfect, right? So now put it over 3n to the third. And now what you want to do, see? You have an n on the outside, an n here. So you can simplify it even more. Cross out the n, not the cube, just the n. And it'll equal, as a final answer, 2 square root 6n over 3n to the second. And this here is your most simplified answer.
I just want to explain one thing, just so everyone's on the same page, is that when you have an n, I can only take an n from the top if it's outside the square root. I can't take this n, because it's under an operation, it's under the half power.
This is not in the square root, so you cannot do that. It's only when the n's on the outside that you can simplify.
This one not in the square root, so I say yes, I can take an n from there.
Yes.
And this, I say, it's not in the square root, yes, I can take an n from there.
Perfect.
And so I just take out an n here, and an n there, and I've taken an n out, because there's basically 3 n's stacked here. I take an n out, and now I only have 2 n's left, 3n.
That leads to the final
squared.
answer.
The next problem that we're going to do is in a slightly different realm of simplifying radical expressions. And this ones you can see we have fractions. But in the fractions denominator, we have square roots. So you can see we have a square root 3 and a square root 12. Now I just want to explain something that actually the square roots act as if they're variables, and they act as any other fraction would. See, I couldn't add 3 over 4 and 3 over 5, right? I couldn't do that.
No, so yeah, what he's trying to say is you must get these to be the same and common denominators.
So I can have a coefficient and then have the square root 3. That would work. I could add those.
Right.
But I cannot have different square roots when I'm adding them, because that's like trying to add 4x and 3y. It just doesn't work. Two completely different numbers. So first we're just going to disregard the 7. We're actually going to factor 12.
That's right. Because this is already simplified. You must factor 12.
We could have done it a longer way by multiplying this by 4, but that would involve simplifying both of them.
We're trying to teach you the easiest way.
We're going to give you the most simple way of doing it, and most energy efficient. So we're going to do exactly like we had before, but actually even a little bit simpler. So we have 12. What this can break down into 3 and 4, right?
Yep.
And these are both under the square root. So the square root of this is 2, but there's no perfect square of 3. So it's just going to stay as 3 for our use in this equation.
That's right.
So now what I have, these are reversible because they're being multiplied. So I have 2 square root 3, 2 is my coefficient, this is my square
Just to recap, just remember that the 2 is basically 2 squared, so you would go on the outside of the radicand, and 3 is 3 to the first, which then you multiply using the half power method, and you'll get that because 2 goes on the outside and 3 goes inside the radicand.
Okay, now we're going to move on to the second stage of the problem.
Yep.
Right here, so we're gonna now what we have is 4 over square root 3 plus 7 2 square root 3.
This was there.
Exactly. This, I simplified this, was my denominator. That's my new denominator, this simplified. So I just stick it right exactly where it's right, because they're equivalent. So now our next step here is going to be, I still can't add these, because look, my numbers, my denominator is not completely the same. I'll look here, this does not have 2 for its coefficient, right? This has an invisible 1. This right here has a 2 for its coefficient, so I cannot add these. So I'm going to actually get these so I can add them. So a very simple step what I'm going to do is simply multiply this by 2.
That's right.
So now we're going to get 8 over 2 square root 3, because as we just explained before, I cannot multiply 2 and square root 3. They're not the same, so I cannot multiply them. And so this 2 just gets tagged along with the square root 3. So now I look and I say, hey there, I see that my denominators are the same.
Finally add them this time. So now we can finally add. So because you have common denominators, you can get to 15. Remember, you don't add these 2 denominators, so you just get 2 square root 3. Now, what you want to do with 15 square root 3, remember, you cannot have a square root on the denominator. So you want to multiply denominator and numerator. So here, remember, square root of 3 times square root of 3 is essentially square root of 9. Unsquare that, it would become 3, so 2 times 3 equals 6. So you just have a plain old 6 on the bottom. And then you would have 15 square root 3, since you can't multiply it. But wait, there's still more we can do. We can simplify, I'm going to move down here, simplify 15 square root 3 over 6, and we can simplify this too. 15 and 6 would simplify because you could take a 3 out of each. So it would become 5 over 2 square root 3. Now this is your final, most simplified answer. I'm Will.
And I'm Ben.
And we'll catch you next week on
Dan the Math Man Tutorials.
Thank you.
Thank you for watching.